Open Google browser. In Google search, type Quirk. Select the first one, Quantum Circuit Simulator. This page will appear. Edit the circuit now. There are many tools. First one, Control, Pauli-X gate, Pauli-Y gate, Pauli-Z gate, swap gate, and a Hadamard gate. So this is output off and off. So block sphere shows the value 0 and 0. Amplitude display also shows the value in the place 0 and 0. These are the two states 0 and 0. We can change the values 1 and 0, 1, 1. First we will select Pauli-X gate. When Pauli-X gate acts on the 0 state, the result will be 1. So it shows the on. Block sphere also shows the value 1. In amplitude display also shows the value 1. Now change the value to 1. The result will be 0. Respectively, block sphere and amplitude display shows the 0. Now select Pauli-Y gate. It acts on the 0 state. The result will be I1. So block sphere shows the value 1. For I, it will show in the amplitude display towards the top. Now change the value to 1 state. The result will be off, that is 0. Amplitude display also shows the 0 value. Now choose the Z gate. When it is acting on the 0 state, the result will be 0. Respectively, the amplitude display and block sphere shows the value 0. Now change to 1. The result will be 1 but in negative. So in amplitude display shows the in negative direction. Next, Hadamard gate used to produce that superposition state. When it acts on the 0 state, it shows the superposition 1 by square root of 0 and 1. When it acts on the 1 state, superposition but in negative direction, that is minus. Next we will choose CNOT gate. We need control and target. So take control and the target. So when the control is 0, no changes will take place in the circuit. Whether the target is 1 or 0, no changes. But when the control is 1, it will change the target value. If the target is 0, the output will be 1. If the target is 1, the output will be 0. Next we will take swap gate. It will swap the values. If the input is 0 and 0, the output will be 0 and 0 only. Respectively, block pair and the amplitude display shows the result. If the input is 0, 1, the output will be 1, 0. If the input is 1 and 0, the output will be 0 and 1. Respectively, amplitude display also shows the values. If the input is 1 and 1, the output will be 1 and 1. Similarly, we can play with circuits. You can combine the single qubit gate with the multi-qubit gates. For example, I'm going to take Pauli-X gate and CNOT gate. So this is combination of Pauli-X gate and the CNOT gate. The output of Pauli-X gate will be given to the input of the CNOT gate. Block pair and the amplitude display shows the result accordingly. Now we'll change the gate. We'll give Pauli-Y gate or Pauli-Z gate. So now Pauli-Z gate and control gate. This is combination of Pauli-Z gate and the CNOT gate. Now output of Pauli-Z gate will be given to the input of CNOT gate. We can see the results in block pair and the amplitude display. We can play with the circuits with different combinations.